Welcome to the potential difference Bi-Toroid transformer video series. This video is being recorded for Dr. Zahn, specifically Dr. Zahn of MIT, who we showed the early stage transformer to in 2008 when we visited him at MIT. This is the updated version, and basically it's a Bi-Toroid transformer 101 tutorial, and I'm going to go through basically the conventional transformer for you, and then show you why the Bi-Toroid transformer is different and how it operates differently. Basically, in every conventional transformer, there's generally a primary and a secondary. The primary delivers its flux through a ferromagnetic core this way, and basically when the flux hits the secondary, it induces a no-load voltage in the secondary. The current that's in the primary coil is reactive current, which means that it's 90 degrees out of phase with the primary voltage. And in an ideal scenario, in an ideal primary, all of the current that goes in on one cycle is returned on the other cycle, and the power being consumed by the primary on no load is the voltage times the current times the power factor, and in this case the power factor is 0. Voltage and current are 90 degrees out of phase, so the power in the primary is 0 watts, and the current in the primary again is reactive current, and the power in the primary is also called reactive power. When the conventional transformer is placed on load, two things happen. The power factor of the load is transferred back to the primary coil. The secondary coil now has current flowing in it, so it produces a back EMF induced magnetic field, which travels back to the primary. When it hits the primary, it lowers the primary's impedance. That causes the primary to allow more current to flow. That current maintains the flux through the secondary coil and maintains the power across the load. If this didn't happen, the voltage across the load would collapse, and there would be no real power delivered to the load. When the conventional coil is placed on load, now the primary coil is consuming real power and delivering real power. The coefficient of coupling for the conventional transformer is 1, which means that all of the flux being delivered by the primary cuts through the secondary and delivers the no-load voltage. Now again, with the conventional transformer on no load, the power factor is 0, and when it's on load, the power factor, in this case it's a purely resistive load, the power factor of the load is transferred back to the primary, and in this case the power factor is 1, and now the primary power is the voltage times the current times the power factor, and the power factor is 1, so we have real power being delivered in the real power being consumed by the primary coil and real power being delivered by the secondary coil. Now, the Bi-Toroid transformer is slightly different in that it has two coils, two secondary coils. The primary delivers its flux this way and that way. The coupling coefficient between secondary 1 is 0.5 and secondary 2. The total coupling coefficient is 1. Now, when the primary is on no load, it's similar to the conventional transformer in that the power factor is 0, the voltage and current are 90 degrees out of phase. The interesting part happens when the Bi-Toroid transformer is placed on load. The primary delivers its flux to the secondary this way and this way. When secondary 1 is placed on load, its flux has now it has 3 flux path route back around rather than 1, as was shown with the conventional coil. The secondary back EMF induced magnetic field can take a high flux path route this way. It can take a very high flux path route this way, or it can take a low flux path route this way, and that's the direction that the flux goes. And when it does that, it stays away from the primary coil. The primary coil power factor does not change from no load to full load, and the secondary coil's back EMF induced magnetic field adds to the flux delivered by the primary coil, maintains, and that additional flux helps to maintain the voltage across the load and the power through the load, and secondary 2 does the exact same thing. The coupling coefficient between the primary and the secondary is 1. The coupling coefficient between the secondaries and the primary is 0. So basically, the Bi-Toroid transformer operates as a magnetic diode. It allows flux to be transferred in one direction, but it doesn't allow flux from the secondaries to couple back to the primary and change the power factor of the primary coil, nor does it allow the primary coil's impedance to go up, because the net flux in the primary doesn't change. So from no load to full load in the Bi-Toroid transformer, the power factor on no load is 0, and the power factor on full load is also 0. So the Bi-Toroid transformer delivers real power, but the primary coil consumes reactive power. And that's how the Bi-Toroid transformer works. It employs non-mutual coupling between secondary 1 and secondary 2 to the primary, and it employs mutual coupling between the two secondaries, and basically that's how it works. Now what this ends up being is a transformer that uses 0 real watts but produces X amount of real power to a load. Thank you very much for viewing.